Okay, so this is our Unit 1 review. So I would strongly recommend that you either download the class notes as a PDF and try the questions in advance, or make sure you pause each one of these questions and do them before I take them up. I won't be showing all strategies. I'll just be using the strategy I feel most comfortable with in the interest of time. So if you haven't downloaded, go do that right now, and I'm going to start. Okay, so we looked at integers and bed mass, so things we wanted to keep track of. Okay, so we have two questions here. So bed mass, brackets, exponents, division, multiplication, addition, subtraction. This is the order that we want to try and do these operations. So you'll notice here I have an exponent and I have multiplication. So I have e and then I have multiplication. So I want to try and do my exponent first, and then we'll worry about this or the addition. So there's my exponent done. I now do my multiplication. 9 times 3 is 27. Negative times a negative is positive. I can drop the brackets on the 25 because there's nothing there to change or multiply or worry or influence the 25. And then lastly, I'm going to add 27 and 25 together, and that should be 52. Okay, over here, this is my concern. This is the one that gets lots of people. 4 subtract negative 5. We talked about subtracting a negative is the same as adding a positive. So the answer there would be 9. Okay, so adding, subtracting fractions. Remember that common denominators are a must for when you're doing adding and subtracting fractions. So we can do this with improper or mixed fractions. It's totally up to you. I'm going to do this problem with improper fractions because I like to work with improper fractions. So 8 times 4 is 32. Come on, pen. Plus 5 more is 37 eighths. Okay, minus 2.5 is 5 over 2. And then plus, again, I'm going to multiply and then add, just as a refresher on how to switch between those. So 16 plus 11 is 27 sixteenths. So I'm in all my fractions are now improper. Now I want to scale them up to get a common denominator. So the first one is going to become 74 sixteenths. So I multiplied top and bottom by 2. Then I'm going to subtract 40 sixteenths. Okay, so I multiplied top and bottom by 8 to get that term. And then the last term is 27 sixteenths. Okay, so now because I have a common denominator, I can just add and subtract the numerators. So I am just going to worry about this piece right now. So I'm going to go 74 minus 40 plus 27, and I end up with 61 sixteenths. I consider it for lowest terms. Probably not that easy to see. I might reduce it to a mixed fraction, so how many 16s fit into 61? 3 of them do for 48, and that leaves me with 61 minus 48 should be 13 left over. 13 16s left over. Okay, so remember, common denominators are a must for adding, subtracting fractions. Multiplying and dividing fractions, we do not need common denominators. If they're there, great. You can do this with mixed fractions, which require an area model, or you can do it with improper. Again, I prefer improper. It just makes, I find that's just much easier with using improper, so I'm going to convert these to improper. Okay, so I have 5 over 2, which is the same as 2.5, and 1 3/8 is the same as 11/8. Once I'm in that format, I can multiply across top and bottom, and I can get 55 sixteenths. And then if I want to reduce that to mixed fractions, 1, 2, 3 groups of 16 is 48, and that leaves me with 7 sixteenths behind. Okay, division. Same strategies as multiplication largely. I'm going to turn this into improper. So 4 times 3 is 12, plus 3 more is 15 quarters, divided by 3 over 2. Now I do have to watch with this. We've spent a lot of time talking about dividing by 3 over 2 is going to give me the same result as multiplying by 2 over 3. Okay, and that's that multiplying by the reciprocal. So I'm going to take my next line. I better use purple. So I have 15 over 4, and then I'm going to, instead of divide by 3 over 2, I'm going to multiply by 2 over 3. Okay, and if that's a little bit rusty, then go back and look at our division lesson. Okay, now I can multiply across the top and across the bottom. I'm running out of room, so I better move this down a little bit and give myself a little bit more space. So this will be 30 over 12, and we can reduce that to 2, which would be 24, and 6 twelfths, which would turn into 2 and 1/2. Okay, we could have also reduced the 30 twelfths to 3 is common, that would be 10 fourths, 6 is common, that would be 5 over 2. Okay. So bed mass and fractions, now we just have to keep track of when we need common denominators, when we have to invert and multiply and all those types of things, but we still have to follow bed mass. So in this question there's brackets, so I'm going to do the brackets first. Okay, so I'm going to change the 3/5 to have the same denominator as the 7/15, so I'm going to multiply top and bottom by 3. Okay, I'm just going to leave this term alone, although I might take the opportunity to turn this into 8/5 and just turn it into improper, just so I save myself a line. Okay, if I add these together, the numerators get added together, the denominators are left alone, so this becomes 16/15. There's nothing else left there for me to worry about, so I'm going to drop the brackets. And then instead of dividing by 8/5, I can multiply by 5/8. Okay, and then in this question we could multiply across the top and across the bottom. It's going to generate some large numbers. We could also do a little bit of a shortcut, so I'm going to do it this way. I'll show you. If we multiply across the top, there's 80 over 120. Let me just double check that. 550 is the 80, yep. 80 and another 40, yeah, okay. And now this can reduce to being 8/12, or it can reduce to being 2/3. Okay, and that would totally work. An alternative approach is, if you notice here, this 8 and this 16, if you divide 16 by 8, you would get a 2. And then this 5 and this 15, if you consider that a fraction of 5/15, it reduces to 1/3, and then you'll notice the only thing that's left in this problem is 2 times 1 is 2, 3 times 1 is 3, and we get the same answer. Okay, just a little bit more sophisticated. Either approach is fine. When we're solving equations, SAMDEB, that's bed mass backwards, is our guide. It's just a guide. It tells us what we should look at first. So when we look at this question here, we see there's adding and subtracting in this question, so we're going to go after that first. So what is the opposite of adding 7? Well, we subtract 7 from both sides. These guys would cancel. We're left with 3a equals, now we have to be careful here, -20, take away 7 more, becomes -27. Please make sure you're using the opposite operations right here. Lots of people do make silly mistakes. Okay, now 3 times a, the opposite of multiplying by 3 is dividing by 3. And then we're left with a equals -9. Okay, so there's the first one done. Next one, I've got a bunch of things going on here. Again, the addition subtraction is going to be the piece I go after first. So I'm going to subtract 1 from both sides. And then I don't like the way this fraction is written, so I'm going to change it to look like this. Okay, I'm going to commit the a to the top. It doesn't matter. 2/5 times a is the same as 2 times a divided by 5. This is the rearrangement of multiplication and division. I prefer this visually. These guys cancel, and now -5 minus 6 is -6. And now here's why I prefer this visually. I want to get rid of this 5 on the bottom. I've made it a clear bottom denominator number, so I'm going to multiply both sides by 5, and these guys will cancel. Okay, now I'm left with 2a equals -30, and my final step would be divide both sides by 2, and I'm left with a equals -15. Okay. Ratios. So when we did ratios, we talked a lot about setting them up as fractions. So in this case, I'm going to rotate the a over the 9 and then the 12 over the 9. So this becomes a over 9 equals 12 over 36. And now I'm just going to use my solving equation strategies. I want to get rid of this dividing by 9, so I'm going to multiply both sides by 9. These would cancel, and I would be left with a equals, and again, if you need to, you can put a placeholder in there if it's absolutely necessary. Some of you might notice that 9 over 36 can reduce. There's lots of different strategies, so I'm going to actually just reduce for the interest of time. Okay, and now I have 12 times 1 divided by 4 times 1, so just 12 divided by 4, and I should come up with a equals 3. Okay. Okay, now this one has 3 unknowns in the ratio on both sides. You can't solve the entire problem at once, but what you can do is you can solve pieces of it. So we need to isolate just one unknown. So when I look at this, I'm going to isolate, let's choose these two first. Okay, because when I underline those, the only unknown I have here is the n. So I would set this up as n over 14 is equal to 22 over 7. Okay, and then I would multiply both sides by 14, and these would cancel, and I would get n equals, now 14 divided by 7 is 2, 22 times 2 is 44. So the n value here would be 44. And now the next pair I would use, okay, I need a complete pair, so I'm actually going to use this group. And notice I skipped the middle term. I can do that, okay, because the proportions should be all held constant. So I'm going to set this up as 2 to 14 is equal to m to 7. Okay, so now again, I'm going to set this up as a fraction. I'll put 14 over 2. Oops, I don't want to do that. That's going to put my unknown in the bottom, and that makes my life a little bit more difficult. So I'm going to backtrack, and I'm going to rotate the m over the 7, which means the 2 goes over the 14. Okay, so now if we multiply both sides by 7, apologize, I kind of ran out of room to write that properly. These would cancel, and I would have m equals 7 times 2 is 14 divided by 14. I would get a 1. So this would be a 1 value. And if we do a quick check, everything on this side is twice as large as everything on this side. Okay, so the 7 and the 14, they're off by twice. 22 and 44, twice. 1 and 2, twice. So always do that kind of checking. Okay, we're almost done. Percent. What is 55% of 420? So if I was doing an estimate, 50% of 420 would be 210. So I need to be around 210 for this problem. So again, we talked about how we can set this up. 55% is 55 out of 100. Okay, and now if I'm looking for a part or a total for this question, I'm looking for the part of 420. And now I'm going to multiply both sides by 420, like such. These cancel. And now I have 420 times 55 divided by 100. I get 231 as my answer, and that's pretty darn close to the 210 I guessed. Okay, last question. A surfboard is regularly $480 but is on sale for 25% off. What is the total cost including the tax? Okay, so let's start with the original price. Let's just get it on the board here. Is $480. The discount is 25%. So 25 out of 100 is equal to n out of 480. Multiply both sides by 480. Okay, cancel those off, and I get a discount of $120. Getting late. I should have done that in my head, but that means my new price is going to be $480 minus the $120, which means I have a new price of $360. So there's the discount taken care of. Now we have to do the tax. Okay, so we'll like a little note to ourselves, this is tax. So 13% of 100 is equal to n out of 360. So multiply both sides by 360. Those cancel. You get an n value of $46.80. And again, that's the tax. That's not the final amount. So now our total cost is going to be our new price of $360 plus our sales tax of $46.80. And that is $406.80. And that is our final amount. Okay, there's a quick review of each topic. You have a task for reviewing. Thanks for tuning in.